Hi, Jen. Hi, Isaac. Welcome to the podcast.
Hi, Robin. Thanks for having us.
Thanks for having us.
All right, let's begin with you, Jen. Where do you work and what do you do?
I'm Jen Marcus. I am the Vice President for Strategic Innovation Programs at Taylor Geospatial.
Wonderful, thank you. And Isaac?
I'm Isaac. I am Director of Research at Taylor Geospatial, and I worked primarily on the Fields of the World project to do the large scale global inference.
Wonderful. Jen, maybe you can give us the intro to Taylor Geospatial.
Sure, happy to. Yeah, we're excited about the organization that we're in right now. We established ourselves as a new organization in January of this year. There were a couple of predecessor organizations, Taylor Geospatial Institute and Taylor Geospatial Engine, and we're obviously funded by the same philanthropist. We took a look at what we were doing across all of that and actually created a brand new organization. As we were going along, we thought it was a merger, and then we realized it's new. We're a new organization with a really acting as a focused research organization. So we have a problem we're focused on solving, and that is unlocking the bottleneck that there is on all of the information held in the vast amounts of satellite imagery that's been collected. And as I think everyone in this room and probably your audience knows, we need the machines to help us get all of that information out of satellite imagery. So we are focused on the application of AI, computer vision, and machine learning to satellite imagery to create global data sets, which is an important fact, or important feature of what we're doing, and doing all that for the digital public good. So everything we do is made open.
Wonderful. I recently did an episode on Fields of the World. That's your product as well. How about a small intro to that for the people that might not be familiar with it?
Well, Fields of the World was our first effort at playing out our mission. And so we started that project a couple of years ago, actually, with the intention to create a global data set of field boundaries.
Hmm.
So field boundaries wasn't our end all and be all. It was our first step. And we built the teams and the tech amazingly in what we feel was a pretty short amount of time to create a global data set of field boundaries.
Right. And what are the unique challenges when you go from a local to a more global kind of task?
Isaac, do you want to take that one?
Yeah, there's way too many. I think I think what you see is generalization issues. So it's very much like machine learning 101. You're training on some in distribution areas, and then you're doing some out of distribution large scale predictions where you don't actually have labeled data. And so in our case, we had to do a huge effort just to make the benchmark data set by working with organizations, getting global other localized field boundary data sets. Because if you look at the literature, most of the existing like field boundary delineation models from satellite imagery, they tend to be very like Eurocentric. Like France has really good field boundaries. Um, some other countries have very good field boundaries data sets, but they don't work when you try to predict on the lower latitudes in South Africa or Brazil, for example. And so we are first had to do that effort of tackling like how do we get a data set that is sufficiently large enough that it can generalize to different areas
Mm.
before we even consider like predicting. And so we went the whole route of spending a year on just getting benchmark data and making sure the data set's clean and high quality, and doing a bunch of evaluations and experiments just to test like generalization and what countries are hard to predict on, what should you use in your holdout set. And so trying to do the science right first before we consider doing this like large scale inference, not to even consider there's all these parameters during inference time that make it really hard to work across different locations. So yeah,
Mm.
I think it's not a surprise to anybody that the model doesn't work amazingly in certain areas, but I think the driver is that this is like version one, and we can clearly see, there's improvements that need to be made. And so we're working on annotating, getting collaborators to help annotate field boundaries in areas that it does perform poorly or the labels are not available. So
Mhm.
there's a lot of more work that's even come out of just this initial global run.
Wonderful. And in terms of the objectives of Taylor Geospatial, how do you kind of map those out in terms of the global context? You say we want each continent to kind of be balanced, or like how do you organize that?
Do you mean in terms of like one data set, the field boundaries data set?
In terms of just the objectives of the project and it being a global project.
Um, well, what we're really, it's an interesting question because, and I think the question actually gets at the way our field typically operates, our field being not a field that you plant things in, but our industry. Um, in that and this is actually the other side of it is what we're working on. So the question that you're asking, I think, is are we trying to focus in certain regions or is that what you're asking?
Yeah, just the what the objectives are and what that means to say we're doing global.
Yeah, yeah. So I've been in this field my entire career. And what I have seen is that all of the tech gets developed and innovated around a use case, a set of use cases, a particular place in the world.
Hmm.
And some of that is transferable to other places in the world. But we haven't gotten there with satellite imagery and AI yet. And so we really started from we know there are fields everywhere in the world, and we know there are people who want to do something with those fields everywhere in the world, whether it's in Kenya and, a coffee farmer needs to prove they didn't deforest their land so that they can continue to sell their crop, or whether it's, looking at large scale farming that's happening in another country for drought purposes. So what we really did was not ask the question, what use case are we solving for or what part of the world? We said, what can we contribute to this body of work, to our field, to the innovation and technology that's available that would lower the barrier of entry for other practitioners who are going to answer their specific use case for their specific region. So, and what I saw at Planet was I was at Planet for a number of years. And what I saw was that we could only solve a problem if a customer wanted us to solve the problem. And, when you're in companies, not just Planet, but in companies that are publicly traded or, have to make a profit, there's not the incentive to do something globally that you can keep using over and over again. And what I realized over a number of years is that there isn't an organization that is in a position to do that. If there was one, I think that, and this is the hypothesis of this whole organization, is that we can actually help the whole industry move forward. And the promise of all the investment that's happened in the proliferation of satellites that are out there, that promise wasn't, hey, give us, to venture capital, give us a bunch of money so we can put data collectors in space. It was give us give us this funding so that we can answer all these problems. But getting data collectors in space is very expensive. And so the next problem set, which is what we're here to help push along, is let's answer some of those things globally that aren't unique to a particular use case or unique to a particular region, so that the people with special questions and problems can work on those.
Hmm.
And that's why we're doing it in the open. It's really, we believe there's some foundational data that is relevant to answering tons of problems, whether it's climate change, food security, deforestation, those kind of things. So we
Mhm.
really truly are not focused on a particular use case. However, now that we've created a global data set, we are going to focus on those things with particular stakeholders and particular users because making the data set better for their needs will feed back in to improving the data
Mm,
set everywhere. So, our hypothesis was let's do it global, tune it again, not in the machine learning sense, but figure out what actual users need from what we've put out there, improve that, and have that cycle continue.
right. And obviously, field boundaries are essential for any kind of crop related task. Could be, detection of what crop is growing or health, etc. So that's why that makes total sense. I guess, Isaac, maybe coming back to you, you mentioned that the first step was finding the data that was available. What did that look like? Was that global already, or was it quite patchy?
It's definitely quite patchy, very messy. As you can imagine, different countries and organizations have different quality, like levels of quality for their labeled data sets. And some don't, some have crop types, some don't. And so there is an inherent like noise in the benchmark data set that is just unfortunately there. I think you find that very common in a lot of remote sensing benchmark data sets. And so the goal really is if I have a sufficient amount of labeled data, a machine learning model will just learn through the noise and predict whatever, optimizes the loss
Mm,
for the during the training run. And so
mhm,
yeah, it's definitely not perfect. And so that kind of segues into doing this global data set and run. Actually, from a lot of conversations that we've had since we've done the release, I've heard it get compared to like the equivalent of OpenStreetMap for field boundaries, where we have this global data set. We're working actually on annotation and editing tools. Hannah Kerner runs, an organization that teaches people how to annotate field boundaries correctly, since it actually is quite particular. And we get compared to like OpenStreetMap, where you can actually edit, and it's like community, annotated and over time. And so over time, we find that a lot of people notice that, oh, in this area, like I noticed you missed some field boundaries. I'd like to like annotate them to add to the data set for everybody to use. And I think that that's really inspiring for us, because somebody had to like do it first before to kind of like bring everyone to come and start annotating for free as
mhm,
a community effort. And we will be retraining a new model based on a lot of these annotations that
mhm,
hopefully will be even better. We'll do more runs. We'll do some backfilling of prior years as well. And that unlocks a lot of applications, right? So like you see a lot of times like global deforestation data sets or above ground biomass data sets that are annual, that you can do change over time. There isn't in existence like a field boundary data set that we can do this with. And so doing the global scale lets us get some kind of number, even if it's an estimate, it's not perfect. It lets us have some kind of idea of like what we're dealing with at global scale, instead of just, as you described, it's very patchy. Certain countries, predominantly first world countries, third world countries, don't have it as good label data. So I think we just don't want it to be as biased towards certain areas, and be
mm,
global and openly licensed for everyone to use.
mm. And just so I can understand how you kind of selected the version one data, did you have a big map and look at the coverage of your labels over a map? What kind of methodology was there to say, yes, okay, we're happy that we now covered the areas that we wanted to cover to the right extent?
Yeah, I think it wasn't like a single time. It was definitely very iterative. So like as you're collecting data, you're running experiments and running predicting on holdout countries to see like what the performance is.
Mm,
And you're visually inspecting, quantitatively and qualitatively. Because there's a lot of issues with like if you're just comparing like pixel IOU, right? Versus like how after polygonization, like do the polygons look good or not? Are
mm,
they sufficient or not? So yeah, there's a lot of very particular details that you have to figure out. But yeah, it's definitely more of an iterative process.
mhm,
And I would like to add something there. Um, and to say like it's not good, right? The first time I saw the map of the benchmark training data set, I was like, this isn't global. What is this? It's not enough. And so, that's one point we wanted to make here today is this was our first pass at both even though, like Isaac said, it was iterative of creating the benchmark data set, experimenting with a whole bunch of models, running it, publishing it, but we're immediately going back and going to expand that benchmark data set massively.
Mm,
It's not enough. Um, but the success there is that we have all those component pieces in place, that we know how to add to the data set, we know where we want to add to it. We've tested tons, and how many models did we evaluate? I mean, at least a couple dozen. So, we're really looking at now where can we improve along all those moving
mm,
parts, the output, plus having the feedback loop from ground truth.
hmm. So that was the first year that got you to Fields of the World version 1, and then the recent release was version 2, which I think primarily addressed South America.
Yeah, so
Uh,
we haven't done a global run with that. But yes, the work that I believe WRI and Hannah were working on was for South America in particular, and that
Mm,
will be added to the new version 2 of the benchmark dataset, which has not been released yet. So that is getting at like wrote back in
mm,
because we do have a lot of stakeholders in South America that are very interested. The fields are wildly different than in other locations, and so um, that in particular is very important for like global food security.
hmm. Right. So Jen, I think how you see this working is that you put the data out there, people adopt it, identify which parts of the world maybe it's not performing so well, and they then engage to bring up the data set and kind of balance things out better.
Yes, at the same time that we are doing things on the technical side that we already know. When we put that data set out, one of the questions we kept asking is, how do we put this out in a way that also lets people know we know where the weaknesses are? Um,
Mm,
and I would say less, well, it's both parts of the world, but it's also use case. What some use cases you don't really need a perfect boundary. In some use cases, you just want to look across a whole bunch of fields and do analytics on, a bigger
mm,
scale. Other use cases, like a precision farming use case is the best one to say, like, we're not there yet at all if you're trying to look at like how much pesticide you put in a particular field. So we're engaging folks who have particular use cases that either it's a good fit for or not, so that
hmm.
we can learn from that.
And possibly a technical sort of point I'd like to explore there. Do different locations have sort of different objectives or different measures that are meaningful to them? So I can imagine if you have lots of small fields that you might have different objectives to having just large fields, for instance.
Yeah, we definitely record metrics that also break it down, similar to like object detection, where you have like average precision for large, medium, small. Like we do similar metrics and analysis based on like hectares, like area of the field.
Mm,
So that is an important piece because we're predicting at 10-meter per pixel. So in a lot of cases, like a field boundary on very, very tiny smallholder fields is not even visible, really. So or if
mm,
you look at like the Sentinel 2 image, it's a pixel, even not. So I think like, yeah, there are limitations with Sentinel 2. And we are looking for partners for higher resolution imagery to rerun on the same labels and
mm,
do some more targeted runs, I think, of certain countries that have high amount of smallholder fields to get those right. Because I think yeah, what you normally see with the smaller fields is you see that they'll either get merged together into like one large field, or they get broken up into significantly smaller fields. But yeah, as Jen kind of mentioned, we've seen a lot of stakeholders and people that have reached out to us that actually are not, they don't care too much about like the precision per boundary. Like they kind of care more about like area and estimates at that scale. So
mm,
they can make these like larger, sort of higher level claims of like their percentage of, land in a certain area is like primarily field. So it's not always that everyone is using the field boundaries themselves. Like
Mm,
we have some folks who have been using like the raw softmax, probability predictions of the semantic segmentation model that we store in cog and zar format. So
mm,
there, because we release all of that, it actually allows people to come up with their own polygonization algorithm. And that's kind of what we wanted. Is we wanted to release all the intermediate artifacts, because we're not prescribing this polygonization method is the best, or
mm,
this thresholding method is the best. Like we want to allow to just have it fully transparent and open so anyone can kind of pick their own parameters.
mm. I'm really curious to understand. You mentioned the different kind of layers to the product. There's obviously a kind of web interface where you can see the polygons. You mentioned that you can actually get the outputs of the models. Can you just briefly describe all of those layers so we can just get an idea of the richness of what was released?
Yeah, so we initially have these. So the model takes in planting and harvest season um, imagery from Sentinel-2 that is selected based on like the location based on the world serial crop calendar.
Mm,
And that's because different areas are going to have different planting and harvest seasons. And so if you just pick one date, basically it's not going to be the correct like a crop will be harvested. There are
mm,
some details of like having a single crop calendar doesn't really work across all different types of annual crops, but it is like a good starting point. You have to pick something to start with. So we do release the Sentinel-2 global mosaics in COG. So we have like per tile, per UTM zone, but we also have like a global ZAR that has all of the planting and harvest season bands in there. We do that for 2 years, so the 2024 and 2025.
mm,
That's all in Source Cooperative. So all of our data is in Source Cooperative S3 buckets. It's not requester pays, so you can query it as much as you want for free, anonymously. And so it's all partitioned with like overviews and multi-scale. And then we have the raw predictions of the model per pixel at 10-meter resolution in the same format, so cog and zar. And then from there, we polygonize those predictions for the field category in particular
mm,
into GeoParquet, into the geometries. And then we have the raw predictions there. And then in the paper that's led by Caleb, for the global field boundary data set, we do a bunch more interesting, like a confidence layer and more filtering. Because initially, like there's about 3 billion polygons, right, in our unfiltered raw data set. But after you do filtering, it comes down to about 860 million per year. And so that seems more reasonable compared to like other global estimates that have been made. And so all of this is out there. GeoParquet is chunked very nicely. And the interesting thing is our Explorer dashboard is just a static front end. There's nothing like particularly special about it. We built it. It has, zoom levels but all of that is built into what's on Source Co-op. So there's no like backend that's hosting it. We're just streaming it from cloud native sources. So what you're seeing when you're zooming in is the PM tiles version of the polygons. And then as you get to a particular zoom level, it starts overlaying the polygons in your point of view.
mm,
But this is all just streaming from cloud storage for free. So if you don't like the application or you have your own specific, custom application you want to build, there's nothing stopping you from like just taking the URL and just building on top of that for
mm.
your own case.
Wonderful. So all of those assets are there. People can just access them, no cost, build their own
Mhm.
front ends, process the data in a different way.
Exactly.
Fantastic.
I'd
Um,
like to add something there if you don't mind, Robin, because everything Isaac just described, and he's talking about COGS and ZAR and Source Cooperative. This is academic work, actually. Like the progress that we made was done with research teams in universities and some researchers who are in companies. And another thing that we decided to do with Taylor Geospatial as a model, because of how our industry is sort of lagging behind the progress that just generally in AI and computer vision for satellite imagery, we decided that we didn't want to wait for academic work to get published and then someone to go replicate it and try it out and scale it up. What we're doing as an organization is doing that as the research is happening. So we fund research teams, but we also fund really talented geospatial technical engineer types to match up with the research teams. And as the researchers are doing work, we're kind of watching and saying, hey, can we put that in this format? Because, what I saw was you go and look at the artifacts of research and you're like,
Mm,
those words make sense to me, but what I'm looking at isn't recognizable from, industry standards. So the fact that Isaac is saying COG and czar and Source Cooperative was a very deliberate decision by our organization to make sure that's happening right alongside the research. So papers get published on the same day, like if we're allowed to. We put this stuff out there for use at scale. And that's one thing that I'm super proud of our organization for doing because we can then really dig into the impact of the work and improve the research questions really kind of hand in hand rather than those things being staggered
mm.
or kind of diverging, which I think often happens.
Yeah, I think that definitely addresses a real kind of common pain point that academic breakthroughs don't often materialize into, real world applications because of the friction of moving it across into
Yeah.
sort of production setting.
And I think that people criticize academics for that. And they shouldn't be criticized. That's the incentive structure that they are employed within requires, and the funding mechanisms usually, say, it should be commercializable, but that's like a check the box kind of thing,
Mm,
not a like someone really did it at scale.
mm,
And so what we from the beginning, our position was we can't expect them to be able to understand all these formats and understand what eventual users might want to do. They have to do what they do, and
mm,
we have to augment that. And that part has been super fun, I think, for all of us. At first, Hannah Kerner was the first one that we kind of talked, and I was like, "Do you think we could do this? Would you be willing to try?" And in the beginning, I called her almost every week because I was like, "Are we stepping on your toes? Are we getting in your way?" And it took a little bit of time. I mean, she always said we weren't. And it took her some time to then realize, like, oh, this is something I can throw over to the tech fellows.
mm,
And at the end of the first year, we had a meeting and she stood up and she was like, this is incredible. It's improved our ability to do the research. And like, I get chills talking about it because I think there's really something there when you let people kind of do what their lane is designed to do.
mm,
And that's been our philosophy also in all of our partnerships. With Source Cooperative, like we're not going to recreate a place to store all this data. We're going to partner with somebody who's doing that and has a similar mission to us.
mm.
And it's been really fun to see how that plays out.
Yeah, and I think it's really delivered, with this first version of Fields of the World and everything that comes with that, all the documentation, software, publications. It's really making a huge impact. I'd love to finish out just by understanding maybe what's next for Taylor Geospatial, and now that you've learned what you have and established this way of working.
Well, I touched on it a little bit. More fields, more fields of the world. We are going to expand that benchmark. We are also going to expand the information we collect with it, like crop type. So we'll make that
Hmm,
predictions and the output data richer. And along those lines, because we have this, work out there, we're working with stakeholders to understand their needs and loop that back in. But we are also kicking off three other threads of work. So one we're calling features of the world, and this was our plan from the beginning, was identify all these component parts in the ecosystem to create a global data set and then come back in and say, okay, we're going to do a different feature type. And how much can we use of what we've already created and how much can we expand that? How much work is it to do the second feature after we've sort of learned what we've learned on the first global feature?
hmm,
So we're right now in the process of deciding what those features will be. And we're really thinking about what would be most impactful and what could we accomplish in a,
Mm.
you know, some time frame that's reasonable. So that's exciting, and we have a team that's lined up to do that, and that's going to be a lot of fun. And then the second project that we're kicking off that's new is around benchmarking. Really, and Isaac can talk about that in a second, so I'll turn that over to Isaac in a second. But to me, that one's sort of not very sexy, but could have a very big impact on how the industry understands the state of the art, and especially in uptake, if we can provide information on what benchmark and model is best for what use case, I think we'll see more
Mm.
uptake in industry. And then the third project is our most innovative, and it's really kind of turning all of this on its head and asking, what if just growing benchmark data sets forever and tweaking these models in their current form isn't going to get us much more improvement, and maybe there's an entirely different way.
Mm.
So we're also looking, that's like kind of the biggest risk, biggest reward area.
Okay.
But Isaac, do you want to talk about the benchmarking a little bit?
Yeah, I'll spend a little bit of time. So we just released a paper on Archive called "No One Knows the State of the Art in Geospatial Foundation Models," and which basically details issues in current evals and GeoAI and foundation models, and issues with benchmarks, and what we should, some recommendations for what we should be doing in the future
Mm.
to sort of get out of this rut that we're in. And this paper is actually a precursor to a toolkit, an evaluation toolkit that we'll be releasing here soon, which tries to standardize. I think one of the recommendations in the paper at the end is that we need to have sort of like an independent third party community led evaluation toolkit that researchers can fork and use. And we're all using the same grading rubric, right? So that's sort of like what that's about. And I think we're planning to maintain it long term, which has been probably one of the major flaws in some other benchmarking toolkits in geospatial AI,
Mm.
because yeah, we just they're normally led by like researchers and students, and then they move on to the next one, so it's not maintained long term, and then everyone kind of just makes their own eventually. And I
Mm.
think that needs to get fixed. The paper coming out though has been really huge. We've had a lot of people reach out and talk about specifically like creating more curated evaluation benchmark data sets that have better translation to like real world applications. I think a lot of the benchmark data sets we've used in the past don't have this actual translation, and are more of like a sanity check, and have kind of been saturated as far as like accuracy and performance. So we
Mm.
need to sort of pivot. Those are all great and great to still benchmark on, but we do need to pivot into very specific tasks like for agriculture and forestry and all urban planning and other applications that people care about. Because I think in industry, people don't on care about like on average, does something do well on Eurosat or Big EarthNet? They probably care more about their particular case that they're working on or task.
Mhm.
So that's really what that's trying to solve.
Wonderful. Well, these are wonderful and I think very meaningful initiatives that you're working on there. Thank you again for joining me today to discuss them, and looking forward to seeing the publications and the future work coming.
Thanks
Awesome.
for
Thanks for
having
having
us.
us, Rob.
Bye then.
Bye.